Hello guys, today I'm gonna start to solve paper 4 February March, Physics 0625. First question. A boat cross a river. The boat points at right angles to the river bank and it travels at speed of 3.5 meter per second relative to the water. So this is the speed of the boat relative to the water. A river current acts at right angles to the direction of the boat points. The river current has speed of 2.5 meter per second. So this is the direction of the river current. And he said the two directions between them, right angle, 90 degree. By drawing scale diagram or by calculation, so he asked you to choose any method. You can choose any one of them and you'll obtain, by the way, the same result if you choose any one of them. Scale diagram or by calculation, determine the speed and direction. As you know, the direction means the angle of the boat relative to the river bank. And let's start to draw. Here we have to draw the vector that represents the direction of the boat or direction of the boat. Here, this will be the first direction, represent the speed of the boat, which is 3.5 meter per second. After that, the direction of the water, river, he said we have right angles between them. So this will be the direction of the river current here. And take care, don't forget to mention the arrow to represent the direction. So here we have 2.5 meter per second. And this is the direction, or this is the speed of the river current. Speed of the river current. He asked me to get or to obtain or to calculate the speed of the boat relative to the river bank. So we have to close the triangle. So here we'll start to close the triangle here from this side to this side. And as we said, don't forget to mention the direction of the resultant here. So this will be, for example, R. This R represent the speed of the boat relative to the river bank. River bank represent as horizontal, as you see. So R, we can get it by the Pythagoras theorem. R equal square root of what? Of 3.5 square plus 2.5 square. So R will be equal to 4.3 meter per second. So here we have 4.3 meter per second. So this is the direction of the boat relative to the river bank. Okay, after that he said what is the direction of the boat relative to the water or to the river bank. Direction of the river bank, by the way, as you see, it's horizontal, not vertical. So he asked me to mention the direction of the boat relative to the river bank. So we have to draw the horizontal line here. If we start to draw the horizontal line here, represent the direction of the river. Direction of the river. So we have to get this angle, theta, and let's mention it as theta 2. We have to get theta 2, which is the direction of the boat relative to the river bank, because the river bank is horizontal. Okay? How can I get it? First of all, we know this angle, all of this angle is 90. So we have to get this angle. How can I get this angle? We can get it by tan theta. So here we have, if it is theta 1, so let's get tan theta 1 equal opposite over adjacent. So 2.5 over 3.5. Okay? So 2.5 over 3.5 equal 0.71. 0.71. So to get theta 1, it will be tan inverse to the 0.71, okay, will be equal to 35.5 degree. 35.5 degree. So this is theta 1. How can I get theta 2? So theta 2 that I want to get it, it will be 90 minus theta 1. So we have 90 minus theta 1, which is 35.5, will be equal to 54.5. 54.5 degree. So 54.5 degree. Okay, that's it. B. Speed is a scalar quantity and velocity is a vector quantity. So you know the difference between vector and scalar. If you remember the scalar quantity, the quantity that has magnitude without direction, but the vector has both magnitude and direction. State the names of one other scalar quantity and one other vector quantity. Scalar quantity like what? Any scalar quantity, any quantity that has magnitude without direction. Like what, for example, like time, mass, anything like this. Time or mass. Okay. What about the vector quantity? Like what? Like weight, for example. Okay. Or velocity. So we can choose anyone. Velocity. Okay. Question 2. Figure 2.1 shows a ship loaded with containers. The ship is made of steel. The density of the steel is 7,800 kg per cubic meter, and the density of the water is 1,000 kg per cubic meter. Explain why the ship floats in the water. Actually, the ship is not made from solid steel. Ship is not made from solid steel. Here we have some air molecules or air spaces in the ship. And also, this means that the overall density of the ship is less than the density of the water. So there are air spaces in ship, 1 mark, and the overall density of the ship is less than the density of the water, the 2nd mark. B. The containers with greatest mass are loaded near to the bottom of the ship. State and explain the effect of the stability on the ship of loading the containers in this way. Actually, here we have to talk about the center of the gravity or the center of mass. Center of gravity or center of mass. Here, the center of the gravity or the center of mass nearer to the bottom of the ship. So this makes the ship more stable. So gravity or greater mass near to the bottom makes center of gravity lower, and the lower gravity or lower center of gravity makes the ship more stable because we have more mass at the bottom of the container. See, crane lifts a container 48 meters vertically upwards. So this will be the height. The mass of the container is 30,000 kilograms. Calculate the energy transfer to the gravitational potential energy stored in the container. You know, gravitational potential energy equal mgh. Mass times gravity times height. Mass is 30,000 here from the question, times g, which is 9.8, times height, which is 48, equal 1.4 times 10 to the power of 7. Question 3. State the principle of conservation of energy. You know that conservation of energy states that energy cannot be created nor destroyed, but it can change from one form into another. B. A wind turbine has a maximum output of power of 1.8 megawatt. The turbine operates at maximum power of 4 hours. So define the unit kilowatt hour. Kilowatt hour is the energy transferred in 1 hour at the rate of transfer of 1 kilowatt. Double I. Calculate the energy produced by the wind turbine operating at maximum power for 4 hours. Give your answer in kilowatt hour. Actually, here we have to convert the unit. Here the power is 1.8 megawatt. So we have to convert it from megawatt into kilowatt because he asked me to get the energy in kilowatt hour. So 1.8 times 10 to the power of 3. So you can convert it from megawatt to kilowatt. 1,800. And you know the energy equal power times time. Power, which is 1800, times the time, which is 4 hours, to get 7200 kilowatt hour. C. Radiation from the sun is the main source of energy for most of our energy resources. State 2 energy resources that are not due to the radiation from the sun. Actually, we have many energy resources that are not due to the radiation from the sun. Like what? Geothermal energy, nuclear energy, tidal energy, anything you want. Question 4. Figure 4.1 shows a metal pan on an electric hot plate. The pan contains 200 cubic centimeter of water. The pan is heated. The temperature of the water in the pan increases. A. Thermal energy is transferred through the metal pan by conduction. State and explain the two ways that thermal energy is conducted in the metal. Actually, we have three methods for transferring heat: conduction, convection, and radiation. So here he asked me to explain the two ways that thermal energy is conducted in the metal. Here we have 3 marks. You know the metal is a good conductor for electricity. Why? Because it has free electrons. So metals have free electrons. And the electrons move through the metal that collide and hit with atoms, transferring their energy. The molecules in the LATs vibrate and pass their energy to the next molecules. So we have 1 mark for each sentence. BI. The water boils and leaves the liquid as a gas. Explain in terms of forces and distances between particles why the gas occupies a much greater volume than it does as a liquid. He asked me to compare between the volume of the liquid and gas. So we have to compare between the attraction force or attractive force between liquid and gas. You know we have free distances between the molecules of the gas if we compare it with the liquid. So the attractive forces between the particles in case of liquid will be more than in case of gas. Why? Because we have more spaces between the molecules of the gas. So the particles in gas are much farther apart than in liquids. We have 2 marks for each one of them. Double I. State 2 ways in which boiling differs from evaporation. Actually, we have a big difference between boiling and evaporation. Boiling happens at specific temperature, which is the boiling point, where the evaporation happens at any temperature below boiling point. Boiling happens throughout the liquid, but in case of the evaporation happen at the surface of the liquid, where the most energetic molecules will escape from the surface. So it takes place throughout the liquid. I'm talking about the boiling, and occurs at a fixed temperature, does not produce cooling. C. The water is replaced with 200 cubic centimeter of milk. The initial temperature of the milk is 20 degrees Celsius. The boiling point of milk is 95 degrees Celsius. The milk starts to boil when 60,700 joule of thermal energy has been transferred to it. The density of the milk is 1.03 gram per cubic centimeter. Calculate the value of the specific capacity of the milk. Give the answer to 3 significant figures. Actually here, you know that Q equal MC delta T, amount of heat or amount of energy. Q equal M mass times the specific capacity times change in the temperature. But here, we don't have the mass, so we have to get the mass. From where? Mass equal density times volume. Density is what? Is 1.03. This is the density. Time the volume, which is 200 cubic centimeter. So you can obtain 206 gram. Actually, here we have Q, M equal M times C times delta T. So if I want to get C, so C equal Q over M times delta T. Q, which is 60,700 over M, which is 206 times change in the temperature, which is what? Here we have 20 degrees Celsius, which is the initial temperature, and final temperature, which is 95. So you have to subtract 95 minus 20 to get delta T, which is 75. So you can obtain 3.93 joule per gram dot degree Celsius. You have the final answer in 3 significant figures. Question 5. A figure 5.1 shows semicircular transparent plastic block. A ray of light is incident normally on the curved surface of the block. The refractive index of the plastic is 1.5 N. I calculate the critical angle for the plastic. You know that N equal 1 over sine C. So the refractive index equal 1 over sine of the critical angle. Just cross multiplication, so you can obtain sine C equal 1 over N. Just get sine C as a subject. 1 over N, so 1 over 1.5 equals 0.67. How can I get C? Just sine inverse for the 0.67, so you can obtain 42 degree. Double I. On figure 5.1, draw a path of the ray in the block after the ray emerges from the block. Here, you know the critical angle is 42. Just you will connect this incident ray to the middle of this protractor. And here we have to draw the normal and just measure the angle of incidence, which is 60. And you know, if the angle of incidence greater than the critical angle, so total internal reflection will take place. So this means that the light ray will return back and reflect with the same angle of incidence, because the angle of reflection, as you know, equal the angle of reflection. Angle of incidence equal to the angle of reflection. So the light ray will return back, and don't forget to mention the arrow on the line. B. Figure 5.2 is a full scale diagram of a lens and an object O, as you see, and this is the focus, which is the principal focus, as you know. This is the principal axis. This is convex lens. The point marked F shows the position of the principal focus here of the lens. Just determine the focal length of the lens. Just use your ruler to measure the distance between F and optical center. You'll obtain 7.2 centimeter. On figure 5.2, draw two rays from the object to locate the image and label the image I. The first ray will be parallel to the principal axis, so it will refract passing through the focus. And after that, the second ray will pass through the optical center unrefracted, unbend, will not bend, just move in a straight line. After that, we will make the extension of these two rays, and we will collect them in this point, so this will be the image, and represent it with I, and write here I, that represent the image. C. Figure 5.3 shows a simplified diagram of an eye with rays from a distant object and the path of the rays inside the eye of a person with a short sight. On figure 5.4 here, draw the additional lens outside the eye to correct short-sightedness and show the path of the rays inside the eye. Here we have short sign. So we have to use what? Any type of lens, so the light rays will be collected on the retina. So we have to choose type of lens that diverge the rays, so they will join on the retina. So we have to use the concave lens. So just draw the concave lens as you see, and write these two rays with the arrows and direction. And after that, when these two rays are emerges from the lens, just they will move slightly bit upward to the convex lens of the eye, then collect it in the retina in this point. Question 6. A. Sound waves have compressions and rarefactions. Explain what is meant by compression and rarefaction. Actually, the compression and rarefactions are the components of the longitudinal wave. Compression, the region where the particles are closer to each other than normal, or the region where there are greater pressure. But in case of rarefaction, region where the particles are farther apart from each other and it has lower pressure than normal. B. We can see light from the sun, but we cannot hear any sound from it. State and explain or state the reason for this. Why? We know the light. The light does not need medium. Why? Because the light is electromagnetic wave. You know the difference between electromagnetic and mechanical. Mechanical wave need medium to travel, while the electromagnetic wave does not need medium to travel. In case of light, the light is electromagnetic wave that does not need medium to travel, but sound need medium to travel. C. During a thunderstorm, an observer sees the lightning almost immediately, but hears the sound of the thunder several seconds later. The thunder and lightning are produced at the same time. The sound of the thunder is heard 9.0 seconds after lightning is seen. The speed of the sound in air is 340 meters per second. Calculate the distance from the thunderstorm to the observer. Very easy. We can get the distance equal speed time multiplied by time. So the D equal V times T equal 340 times 9 equal 3,100 meter. I or D. In lightning strike, there is a current of 3.0 times 10 to the power of 4 ampere for 48 milliseconds. Calculate the charge that flows. Actually, here we have to convert from millisecond to second. So 48 times 10 to the power of negative 3. So we can change or convert from millisecond to second. And here he asked me to get the charge. You know, Q equal I times T. Q, which is charge in column, equal I, electric current in ampere, multiplied by time in second. So equal I, which is 3.0 times 10 to the power of 4 ampere, times 48 times 10 to the power of 3 to convert it from millisecond to second. So you can obtain 1,440 means 1,400 column. A. Define the potential difference. Potential difference is the work done per unit charge. Potential difference equal work done over charge. W over Q. Here we have 2 marks. So the work done is passing charge through a component just to get the 2 marks. BI. State the equation which defines the electromotive force. Electromotive force E equal W over Q. W, which is the work done as we said, over Q, which is the amount of charge in column. So just E over Q to get the mark. Double I. The EMF of the battery is 9.0 volt. The battery is in a circuit. So here we have V. Calculate the work done W for the battery when it moves a charge of 30 coulomb around the complete circuit. How can I get W? You know V equal W over Q. So just cross multiplication. Just write the W as a subject times V equal V times Q. So V is 9.0 times Q, which is 30, to get 270 joule. C. A circuit of direct current power supply, DC power supply, a lamp and thermistor. Draw a circuit diagram of these components connected in series. Here we have the battery, and here we have the lamp, and here we have the thermistor. Only you can draw them in a series connection. He said in series. So here we have the battery, and just we can connect it to the lamp and connect it to the thermistor. And don't forget to get the correct symbol for each one of them, the battery and the lamp and the thermistor. Double I. Explain what happens in the circuit you have drawn in CI when the temperature of the thermistor is increased. You know the relation between the temperature of the thermistor and its resistance. And we know that the resistance of thermistor decreases when the temperature increases. We have inversely proportional between them. And the resistance of the circuit falls, or greater current flows in the lamp, so the brightness increases. Question 8. Figure 8.1 shows a horizontal flat coil in a magnetic field. The coil is connected to a cell. The coil rotates between the 2 poles of the magnet, which is N pole and S pole. A. Determine the direction of movement of the side AB relative to the plane of the coil. what will be the direction of this side? Actually here, to mention the direction of the force, we have to mention the direction of the electric current and the direction of the magnetic field. The direction of the magnetic field start to move from N to S. What about the direction of the electric current? Here we have the cell, and you know that the direction of the current through the circuit that is connected to the cell start to move from the positive pole and return back to the negative pole. So this is the direction of the current, as you see. So we have to use Fleming's left hand rule. The first finger will point toward the direction of the magnetic field. The second finger will point toward the direction of the current. So your thumb will point to the direction of the movement or direction of force. So we can represent it here in this figure. So the first finger will point toward the direction of the magnetic field from N to S. The second finger will point toward the direction of the current from A to B. So what about your thumb? Will point to the direction of the force, so it will move downward or into the page or anti-clockwise. B. Explain how you determine the direction in A. Actually here we have direction of the current and direction of the magnetic field and direction of the force. Each one, the direction of the current perpendicular to the direction of the magnetic field. Direction of the magnetic field perpendicular to the direction of the force. And the magnetic field from N to S. Here we have 2 marks. So the current, magnetic field, and motion at right angles to each other. Magnetic field from left to right. C. State and explain what happens to the coil as it reaches the vertical position. What happened to this coil when it reaches the vertical position? Actually, when the coil reaches the vertical position, it will stop. Why? Because it will not cut the magnetic field lines. So it will stop. So we can say the coil will stop, or the coil vibrates, wobbles backward and forward. Here we have 2 marks. So the first mark, coil stops because it will not cut the magnetic field, and coil vibrates or wobbles backward and forward, or coil pulled back by the force acting on it. Coil stops means coil overshoots. D. To operate as a motor, split ring commutator and brushes are added to the parts shown in figure 8.1 here. We can add split ring commutator and brushes. Explain the effect of the split ring commutator and brushes on the action of the motor. Actually here, the split ring commutator, you know that it reverses the electric current each half cycle. When the coil is at right angle to the magnetic field, it will reverse the current. So it will be move continuously without any stop. What about the brushes? Just provide the contact between the coil and power supply to conduct electric current. So the coil rotates continuously. We have 3 marks. So each line 1 mark. Question 9. A. A nuclear power station has a reactor where controlled nuclear fission of uranium-235 takes place. I. Explain what is meant by nuclear fission. Actually, the nuclear fission is the reaction in which the nucleus of an atom splits into 2 or more lighter nuclei and some neutrons and greater amount of energy. And this is opposite to the nuclear fusion. The nuclear fusion, where the nuclei of hydrogen isotopes combine with each other to form heavier helium atom and neutrons and greater amount of energy. State one advantage and one disadvantage of generating electrical power in nuclear power stations compared with electrical power generated using wind turbines. Here we want to compare between the nuclear power stations and wind turbines. Actually, the advantage for using the wind turbines, no pollution, as you know, so it does not use fossil fuels, does not cause any air pollution, produce large amounts of energy. But the disadvantage of using the nuclear power stations, not renewable, resources not renewable, means can be finished. B. Deuterium is an isotope of hydrogen H with 1 proton and 1 neutron. Nuclear fusion occurs when 2 nuclei, as we said before, of deuterium combine. An isotope of helium and the neutron are formed. Just we want to represent it into equation. So use nuclide notation to write down the nuclide equation for this reaction. Here we have deuterium H12 will combine with another deuterium H12 to form helium and the neutron. As he said, the neutron is 0, 1. And here H12 and here H12. So the helium will be 2 and 3. Why? Because if we add 3 plus 1 equal 4. And here we have 2 plus 2 equal 4. And here 2 plus 0 equal 2. And here 1 plus 1 equal 2. Question 10. A. The time taken for Mars to orbit the Sun is 690 Earth days. The average orbital radius of Mars is 2.28 times 10 to the power of 8 kilometer, and Earth day is 24 hours. Calculate the average orbital speed of Mars in kilometer per second. So the speed equal distance over time. What about the distance and what about the time? Distance is the orbital circumference, which is 2 by r, 2 times pi times r, which is the orbital radius over time period. So 2 by r. What about the radius? Is 2.28 times 10 to the power of 8 over time, which is 690. This in days. We have to change it into second. So times 24 from day to hour, and from hour to second we have to multiply by 3600. It will give me 24 kilometer per second, the same unit in the question. B. State the shape of the orbits of the planets. You know it's elliptical. Light from a distant galaxy is redshift. Explain what is meant by redshift. With redshift, in case of redshift, the wavelength increases. So the change of the wavelength, which occurs when the galaxy is moving quickly and the wavelength increase. Double I. State the quantity that the redshift of a galaxy is used to calculate speed or velocity, and it's directly proportional to the distance.